Hello. So this is the re-recording of the class on Monday, the 28th. So obviously we're not going to get all the questions and everything else from the class, but I am going to try to go over all the 15 questions that we did do in class in a similar manner. So at least you have those notes as well. So the first couple of questions is looking at changing degrees from a decimal number to a degrees, minutes, and seconds. Degrees, minutes, and seconds are used a lot of times in navigation. Because it's a lot more accurate than doing it as a decimal. We'd have to carry out the decimal to like 5 or 6 decimal places to be able to do degrees, where in degrees, minutes, and seconds, I already have that built in, which makes my life a lot easier when you're trying to be a lot more accurate. And so if you think about it, if you're on the ocean, being within a second is a big difference. If you're a hundredth off in a degree, that's going to be a lot more off the longer you go. So degrees, minutes, and seconds. So in this problem, we've got 22 degrees. And it's not letting me write today. There we go. So 22 degrees, 52 minutes, and 46 seconds. So to change this to a decimal, I'm going to take each of these numbers and I'm going to divide them by 60. And then I'm going to add it to the one before it. So I do 46 divided by 60. So I get 52.7666. And we just keep going out. So that's minutes. And now I'm going to take that number. So on your calculator, keep that whole number, add the 52, and then we divide that number by 60. So then my final answer is 22.8, and they want thousandths, so 79 degrees. So that would be the answer I would put in for this one. So we got 22.879 degrees. Now the next one, the next topic we're looking at is actually going the other direction. So we're changing degrees, minutes, or the decimal answer into degrees, minutes, and seconds. So we're going to do a very similar thing. So 39.359. So I've got 39 degrees, and then I take the 0.359 and I multiply it by 60. So instead of dividing by 60, I'm going to multiply by 60. In this case, I get 39 degrees and 21.54 minutes. And now I'm going to take the 0.54 and times that by 60. So I get 39 degrees, 21 minutes, and 32.4 seconds. Now they want you to round it to the nearest second, so we're just going to do 32 seconds. So I've got 39 minutes, or 39 degrees, 21 minutes, and 32 seconds. The next two questions we're going to look at is changing degrees to radians and radians to degrees. So the degrees measurements are the ones that typically you're used to seeing. 0 to 360 degrees is the entire circle. Radians is actually looking at the circumference. So it's a little easier to use to figure out calculations for sector length and arc length, those things, because my angles are in the pi for that circumference already. So on my degrees goes from up to 360 degrees for a whole circle. My circumference of a unit circle would be 2 pi. So if I'm going from degree or radians to degrees, so radians to degrees, I'm going to do 180 divided by pi. That's basically what we got there. Degrees to radians, I'm going to do the opposite. I'm going to do pi over 180. So for this problem, I've got 3 pi over 2, and I want to change that to degrees. So I'm going to multiply that by 180 over pi. So the pi's cancel out, and I'm left with 270 degrees. That's 270 degrees. The next one's the same thing, except it's going the other direction. So I've got the 214.3, and I want to change it to a radian measurement. So they say they want this one with no pi. So, but I'm going to multiply by pi over 180. So we're going to take use the calculator for this one. So I'm going to do 214.3 times, we're using the pi button, divided by 180. So I get, for this case, we want the nearest hundredth, so 3.74 radians. So this really right here, that's the formulas you need to be able to do those two conversions. The next couple ones that we're going to look at is looking at doing, we're doing coterminal angles. Sorry, we're going to do sectors in a few minutes. So coterminal angles are looking at angles that are between the 0 and 2 pi or between the 0 and the 360. So if my angle is any other one outside of that, I have to get it between that. So the first one I have is the negative 17 pi over 10. So that's obviously less than 0. So I'm going to add 2 pi. And in this case, I'm actually going to add 20 pi over 10. So I get 3 pi over 10. Now that's obviously bigger than 0, and it's less than 2 pi, which is 20 pi over 10. So that's going to be the number for that one. The 900 degrees, that's obviously bigger than 360. So I'm going to subtract 360. So if I subtract 360 from that, I get 540. Again, it's still above 360, so I'm going to have to subtract 360 again. And I get 540 minus 360, which for some reason I can't do in my head at the moment, is 180. So that is going to be my degrees. So we have 3 pi over 10 and 180 degrees. So again, you want your angles between 0 and 2 pi and 0 and 360. The next one we're going to look at is being able to figure out the arc length. So if you remember, so arc length is like circumference. So my circumference of my formula is circumference equals 2 pi r. That's my radius. And that is my radians. That's the whole circle. So for arc length, we're going to do radians times radius. So for this problem, I've got a circle with a radius of 15 and a central angle of 3 pi over 4 radians. So I'm going to do S equals 3 pi over 4 times 15. So when I do that, I do 3 pi divided by 4 times 15. And they want this to the nearest 10th. So that'd be 35.3 centimeters. So when you're doing arc length is radians times radius. When I'm doing sectors like area. So if you remember, the area of a circle is pi r squared. So my sector, so again, that's half of my radius. So it's my radians divided by 2 times my radius squared. So for this problem, my radius is 3 and my angle is pi over 3. So my sector is going to equal pi over 6 times 3 squared. So we've got pi divided by 6 times 3 squared. And I want this one to the nearest tenth again, so I got 4.7 centimeters squared. So the nice thing about doing sectors and arc length is that if you can remember the area formula and the circumference formula, you can easily determine those. You don't have to memorize a new set of formulas. You just have to remember that that pi in the front is basically your radians of the circle. So. Next thing we're going to look at is standard position of angles. So in this case, this is where the unit circle is going to come into play. So if you look at your unit circle is this. This is all our angles and all our radians built into it. So our circle, we start off at 0 and we move our way around. So you're going clockwise direction over this way. So we've got 0 to 90, and then 90 to 180, and then 180 to 70, and then back over to 360. So if you think about my coterminal angles we were talking about, they keep repeating themselves in this. So that's why the unit circle really comes into play. It's also going to help me figure out my points in a little bit. We're starting to look at the trig functions and the initial and terminal points of angles. So if we're looking at standard position, the problem that we had was we were looking at 3 pi over 4. So that angle right there is going to be bigger than 1/2, but less than 1. So I know it's going to go over to here. So it's halfway between 1/2 and 1. I'll show you one more of those. So now this one's 5 pi over 3. So I know it's bigger than 1. So I know it's going to be over here. So now the question is it closer to 3.5 or to 1? Now, 3.5 is probably closer to 3.5, so it's going to be right there. And you can use your unit circle. Wasn't right on the line. Oh, 5 pi over 3 is actually bigger, so it's here. 5 pi over 3 is bigger than 1 or 3.5, so it's on that side. This is why it's always important, as I was going to say when I did that one, is to always go back and look at your unit circle because it actually will tell you where those numbers are. So I would print out this unit circle and have it right in front of you at all times when you're doing these problems. It's definitely going to make your life a lot easier. Because the next problems that we're looking at, so this one's looking at terminal angles or terminal points. So if we look at the unit circle, we're looking at 3 pi over 4. So on my unit circle, I want the answer for 3 pi over 4. So if we look at 3 pi over 4, 3 pi over 4 is right here. So that is my terminal point. So it's negative square root of 2 over 2, and then square root of 2 over 2 is my x and my y. So that's what we put in. So negative square root of 2 divided by 2, and then square root of 2 divided by 2. So again, this is where those unit circle really comes into play because it's going to give you all this information that you can easily quickly look at and pull it out. If we were in class, I'd have actually had you create the unit circle, but in this situation, you can print it out. The next thing we're going to look at is being able to find other points on it. So when we're looking at the unit circle, if we're looking at this point, say right here, I actually have a triangle, and it's a right triangle. So this is my radius, which in the unit circle is always 1. This is my x value, and this is my y value. So I can use the Pythagorean theorem if I know at least 2 of those 3 pieces to figure out the answer. So in this problem that we were looking at a second ago, we've got a few pieces of information. I've got my x is -4/5, and I know it's on the unit circle, so I know my radius is 1, and we're looking for the x. And they're telling me that this is also in quadrant 2, which means my y is going to be positive because we're going up into quadrant 2. So we could do the Pythagorean theorem with this one. So we do a squared plus b squared equals c squared. So we're going to have -4/5 squared plus y squared equals 1 squared. Now, there is a nice little trick to this. If I took the bottom of my fraction, so in this case it's a 5, and I could make that my radius over on the other side, I don't have to worry about doing fractions. So what I'm going to do is I'm actually going to do the -4 squared plus y squared equals 5 squared. So 16 plus y squared equals 25. Y squared equals 9. So y equals 3. So my y is not going to be 3. It's actually going to be 3/5. And since y is positive, we use the positive value of that. If it was in the fourth quadrant, third quadrant, or the fourth quadrant, the x could still have been the -4/5. If it was in the third quadrant, my y would have been negative, however, down the bottom. So we do 3/5. Next one, we want to find the exact value of cosine. When we're looking for exact values, we're going right back to the unit circle. So now, if you go back to my unit circle, when we're looking at my unit circle, we're looking at 4/3, so we're looking down here. So when we're doing this, sine, and actually I'm going to change this color here real quick, and I'm going to, so sine is opposite over hypotenuse. So if we're looking at my triangle here, if we're looking at a triangle, and my angle's here, opposite is my y value. So your sine is going to be your y. Cosine is adjacent over hypotenuse. So that is my x, because that's that side there. And then tangent is opposite over adjacent. So that's y over x. The inverses of those, we have cosecant, which is, or the reciprocals of those. So cosecant is 1 over y. Secant is 1 over x. And cotangent is x over y. So whenever they're asking you for exact values, you're going to go to the unit circle because that's the only way for us to get exact values. So for this one, we're looking for cosine. So cosine of 4 pi over 3 equals, it's the x value, so -1/2. So we go back. And I'm going to plug in -1/2 for my cosine. Next thing, same thing. This time we're looking for tangent and cosecant. So I'm going to go back to my unit circle, and we're looking for it on 5 pi over 3. So I'm going to go back to my unit circle, and I'm actually going to go back to what I had originally there so you can see it all. So we're going to change my, so we're looking at 5 pi over 3. So we're looking at this value right here. And we wanted the tangent and cosecant. So we want tangent and cosecant. So when we're looking at tangent, it's y over x. So that means I'm going to have the y, which is negative 3 square root of 2, or 3 over the square root of 2. And we're dividing that by 1/2. So we're basically be multiplying it by 2 over 1. So I end up getting negative 6 over the square root of 2. And you don't actually have to rationalize it in this topic we found out the other day. So now my cosecant is the reciprocal of negative 2 over the square root of 3. So this is my tangent, and that's my cosecant. So negative 6 over the square root of 2, and then negative 2 over the square root of 3. So we go back. So this one's negative 6 over the square root of 2. And then negative 2 over the square root of 3. All right, let's. Oh, it was a square root of 3. Okay, I wrote it wrong. I wrote the square root in the wrong spot. So your tangent was negative square root of 3 over 2 divided by 1/2. So it ends up being just negative square root of 3 because the 2's end up canceling each other out. I put the square root in the wrong spot. So that's just negative square root of 3. Same thing on this one. The difference is we need to get our coterminal angle before I do it, because 9 pi over 4 is not on my unit circle, and neither is negative square root of, or negative 210. So I do the 9 pi over 4. That's bigger than 2, so I'm going to subtract 8 pi over 4. That gives me pi over 4. And then negative 210, I'm going to add 360 to that. And I get 150. So we're looking for the sine of pi over 4, which will be the y value. And then we're looking at the secant of 150, which would be 1 over x. So let's go to my unit circle. And 150, my 1 over x, is going to be my x is square root of 3 over 2. So I get negative 2 over the square root of 3. And for pi over 4, my y is square root of 2 over 2. So we get negative 2 over the square root of 3. Oh, I got them backwards. Square root of 2 divided by 2. And negative 2 divided by the square root of 3. The last two topics are looking for reference angles. So let's go back to my unit circle really quick and notice something. So all my points over here repeat themselves all the way around. So this 1/2, or square root of 3 over 2 and 1/2, is the same thing as directly across from it. It's also the same thing directly across this way. And it's also the same thing directly up and down. So all these points right here are related to each other. So if I can take my angle and basically find the angle that's going to be in that first quadrant for it, I'm going to find the angle that, or the value that'll work. So I'm going to find my reference angle. So when we're looking for my reference angles, I'm going to look at, no matter where the angle is, I want to get back to this center line. So if I have an angle that's over here, let's say I have that angle, I'm looking to go back to that. So in this case, it's going to be pi over 6. Here's my reference angle, because that's how much I would need to get back to that center line. If I have a line over here, say 120, to get to here, that's 60 degrees. If I had an angle down here, say 5 pi over 4, to get back to that one, it's going to be pi over 4. So the reference angles is whatever I need to get back to that horizontal line in the middle. So in this problem, I have negative 10 pi over 9. So the first thing I have to do is I want to get it on my unit circle. So I'm going to have to add my 2 pi basically to this one to get it over there. So negative 10 pi over 9 plus 18 over 9 pi. So I get 8 pi over 9. So now the question is where does that fall? So that's pretty close to 1. So if I look at my unit circle, 8 pi over 9 is going to be right about there. So I'm looking to go to that. So I'm looking to go to 1. So that's just going to be pi over 9, because that would get me to 1. So we go back to my answer. My answer is going to be pi over 9. So again, it's whatever's going to get you back to that center angle. Last one, same thing. This one's just with degrees. So I've got the negative 560. So I'm going to add 360 to that. I get negative 200. I'm going to add 360 to that. And I got 160. So 160 is closer to 180. So that means to get to 180, I'm going to do 20 degrees. So my reference angle in this case is 20 degrees. And that's the topics that we did on Monday.